Problem 4, page 489. Make sure you've opened the book that page and read the problem before we begin. It talks about two plates at two different potentials. So we can draw them in like so. And I'm drawing them in this orientation so that I can make clear a gravitational analogy. So this plate is at one potential V2, this one is at another potential V1. And we're asked what's the potential difference between the two plates, V2 minus V1. And we're also asked which is the higher potential, V2 or V1. And the information we're given is that an electron moving from one plate to the other gains a certain amount of kinetic energy. Now, before we go on with that, let's just think a little bit. You can think of electric potential as being analogous to gravitational potential, or you can compare electric potential energy to gravitational potential energy. So if we switch to a gravitational analogy for a moment, imagine this is a shelf high up and this is the ground. If you lift a mass up to here, you do work to lift it up against the gravitational pull. And if you then let it go, it will fall spontaneously towards the ground, converting potential energy to kinetic energy as it falls, until when it reaches the bottom, just before it hits, it has its maximum kinetic energy. And the same thing applies to electrical charges. Okay? But because there are two types of electric charge, we've got to be careful about which kind of charge we're dealing with. Now, a positive charge, you have to put in potential energy, electric potential energy, in order to lift it up from a low voltage to a high voltage. So if this was 0 volts and this was 10 volts, we'd have to put in work in order to lift a positive charge up. And then we'd have a positive charge sitting here with potential energy. If we then released it, it would accelerate from the high potential to the low potential and gain kinetic energy on the way. So a positive charge is going to accelerate from plus 10 or whatever, from a high voltage, a high potential, to a low potential. But this question deals with an electron. And because it's oppositely charged, it behaves in the opposite way to a negative charge, to a positive charge. So our electron, if this is the high potential, our electron, we're going to have to start here and put in potential energy to move it to a lower potential because it's a negative charge. So we're putting potential energy in to move from high to low, and it is then going to gain kinetic energy as it falls, strangely enough, uphill. As it goes from low potential to high potential, it gains kinetic energy. Because of the negative charge, an electron actually has a lot of potential energy when it's at a low potential. And that's just because our convention is that we're always talking about test charges, positive little charges, when we're dealing with electric potential. So with that in mind, if we start with an electron here that has some potential energy, it's going to fall and gain kinetic energy. And that kinetic energy that it gains is going to be equal to the potential energy that it loses. And we're given that number. It's 7.45 times 10 to the minus 16 joules. When we go back to the question, it accelerates from plate A to plate B. So the way I've set this up, this is plate A, this is plate B. And because the electron is accelerating towards plate B is at the higher potential. So straight off we say B is a higher potential. And let's, instead of messing our numbers up, let's call this VA, the voltage at plate A, and VB. And we're trying to find VB minus VA. Well, we know the change in potential energy, which is the same as the kinetic energy. It's 7.45 times 10 to the minus 16 joules. And that's equal to the change in potential multiplied by the charge. Remember, potential is energy per charge, so V is energy per charge. Solving this, we get that the change in energy is equal to the change in voltage times the charge. And so we actually want this form of the equation to find the potential. So the difference in potential is the energy, 10 to the minus 16 joules, and then it's an electron, so it has one charge, and the charge on the electron, you can look this up on your data sheet, it's 1.6 times 10 to the minus 19 joules. And then if we round off to estimate, that's going to be approximately equal to 8 times 10 to the minus 16 divided by 1.6 times 10 to the minus 19. Well, 8 over 1.6 is 5. 8 over 16 is a half, so on. You should be able to do that, spot that. So it's about 5, and 10 to the minus 16, 10 to the minus 19, that cancels out. So it should be about 5,000 volts. And that's just to check so that the numbers that come out of your calculator are reasonable.